Hello and a very good evening to everyone. Today we are going to continue with our first chapter, the solar system. The topics we are going to cover today, starting with types of years, types of days, and then twilight period. After that, we'll also do some very important questions that come in the exam from this chapter. So, starting with types of years. What are the types of years? Sidereal and tropical. So first we'll go through the definitions. What do the definitions say? And then we'll understand the meaning of these. What are the special things about these and what to remember about this? So the definition says time interval elapsed between two successive conjunctions of Earth, Sun, and a distant star is called sidereal year. A distant star, why? Because if we took a star close to us, the relative motion of the Earth to that star would matter a lot, like Sun is a star. So if we took Sun as the reference, Earth also revolves around the Sun. So the relative motion will make it difficult for us to mark the conjunction. So we took a distant star so that the star, Earth, and Sun, when all of these three align, there will be only one instance when this will happen. That's why we took a distant star. Talking about the definition of a tropical year, so the time interval elapsed between two successive conjunction of Earth, Sun, and the first point of Aries. Now, what is the first point of Aries? It's a very important point. It is not a star, it is not a constellation. It is called also the prime meridian of the sky. Why? It is actually a mathematical value, a actual imaginary location in the space, which is located by the scientist for our use. It is not an actual star. You need to remember this. So, we are done with definitions. Now let's understand what's this sidereal year and what's the tropical year. What's the meaning of this? What's the essence of this? So, sidereal year is basically the comes into use for the scientists as it is the exact point when the Earth, Sun, and the distant star aligns, and this gives the accurate value of one completion of revolution. So scientists use it in astrophysics, but why don't we use it? Because it does not align with the seasons. If we were using sidereal year continuously, then there would be a time when in December it would be summer season for us Indians. But that's not true. That's not a good thing. It should remain in the season it happens. That's why we use the tropical year. The benefit of the tropical year, the seasons always occur in the same months. Like June, July is the summer season. It will always occur in June, July. For us, winters happens nearly November, December, January months. So winters will remain in these months only. But if we were using the sidereal year, it would have been completely disrupted in few years. Also, few facts that you should remember. The sidereal year's duration is 365 days, 6 hours, and 9 minutes, whereas the tropical year's duration is 365 days, 5 hours, 48 minutes, 45 seconds. It's accurate, good to know. And that's mostly about the sidereal and tropical years. We should now proceed to the types of days. Also, one thing, if you have any doubts regarding anything I've taught or anything from this chapter, does not matter that from which book it is, from which place it is, you can send me an email, or I would also provide my phone number in the end of the video. You can ask the doubt for free. I would not charge anything for it because actually it would help me to upgrade my concepts, to update all of the things I know, and to get to know new things. So feel free to ask me. Copy it down, then we'll proceed to types of days. So I hope you have noted it down. Let's quickly erase it and proceed to the next topic, types of days. So basically there are three types of days: apparent solar day, mean solar day, and sidereal day. We'll start with a diagram, understand what are the differences in it, and in the end I'll write down the definitions and important points so that you can note it down. So let's start with the diagram. I'm again using the two foci and a string to draw it. So this is the orbit of our Earth. This is the Sun, and we'll start with apparent solar day. So what does the definition say? The time interval elapsed between two successive transit of our real Sun over the observer's meridian mark one apparent solar day. So there were a few key points that needs to be elaborated. That's real sun. The term real sun is being used. Why? Is there a fake sun? No. Later on, we are going to also study the mean solar day. In that, we are going to see that there is an imaginary sun. So that's why in this, we use the term real sun to not confuse between those. So let's understand what's apparent solar day first. So, as we imagine that in one rotation that 24 hours is covered and that marks one day, but here if you see, because of the revolution of Earth, after one rotation the sun is not reached. Let me explain. So this is the point where Earth is pointing at the sun. After one rotation, let's say in one day, it reached here. So now it's pointing here and there is no sun. Now it needs to rotate a bit extra to point towards the sun. So the extra rotation causes extra time, and that's why the apparent solar day is not a constant time interval. Like the apparent solar day is not equals 24 hours every day. It varies depending upon where the Earth is. Let me give you another example. Similarly here, if it reaches this part of the orbit, let me correct it a bit. Just a second. Correction was needed because in this part of the orbit, Earth moves a bit slower because of the law of areas as we studied in Kepler's laws. That's why I made it closer. So let's understand. It traveled this much in one day. So again, we see this was the point where the Earth was pointing to our sun. After it's reached here, it again needs to turn a little bit extra to point towards the sun. There must be some angle. Any idea what it may be? It is very much exaggerated so that it's easy to understand. The angle is not that big in real. The angle is as small as around 50 minutes or 1 degree only. So this is the exaggeration is just for your understanding. It is approximately 1 degree only. So you could make it around in the way you like. Also, in the book published by R.K. Bali, he has mentioned a very good point. The difference it causes, the extra rotation, remains around plus minus 20 to 30 seconds only. But the collective difference that gets accumulated over time reaches around 14 to 16 minutes. So, what do we understand by this? It explains why the duration of apparent solar day is written as 2344 to 2414. Let me write it down. This. This is the exact value as given in our books for apparent solar day. It sometimes remains below 24 hours, then it goes above 24 hours. This is the main point. This is why we invented mean solar day, because people were saying that the duration of day is varying constantly. We cannot rely on it, even though it's in minutes only, but it matters. So we created mean solar day, and the definition of mean solar day says that it is the time interval elapsed between the imaginary sun rotating around the earth with a constant speed of 15 degree per hour. 15 degree per hour, if you calculate for 360 degree, it will give exactly 24 hours. So the mean solar day, the time interval for that is exact 24 hours. Let me also write it down. So now we notice two things. For apparent solar day, the time is not constant, and for mean solar day, the sun we are taking is completely imaginary. It's not real, it's not with reference to something real. That is why we got a need to develop another system of monitoring our days. That's a sidereal day. So the sidereal day uses a far star to measure one day, because the relative motion of Earth with respect to that star, which is very far from us, would not matter much. That's why we take a sidereal day. Duration 23 hours 56 minutes. If you remember, also while studying types of years, we took a sidereal year using a distant star. Exactly the same concept. Why? Because with respect to objects, stars which are very distant from us, the relative motion will not matter much. So let's write it down too. So 23 hours 56 minutes. You could note it down, draw the diagram, and then we could proceed to the definitions part. So there was one more thing that I thought needed a bit more of explanation before we go to the writing part. This apparent solar days difference of 16 minutes and 14 minutes from mean solar day. Why is that? How is that much? As you remember earlier, I said, as said by R.K. Bali sir in his book, that the difference in apparent solar day is 20 to 30 seconds compared to mean solar day. So from where does the 14 and 16 minutes difference come from? The accumulation that happens over time, that leads to it. How? Let's say here, the 30 seconds of extra rotation was required to cover this 1 degree. So now what? One more day will pass. Let's say Earth reaches here. And similarly, a bit more of extra rotation will again be required to reach towards the sun. It's again a bit too much exaggerated, do not think it's like 45 degrees. It's very close to 1 degree, half a degree, like that. So what happens every day when this happens, when the extra rotation of 30 seconds is required compared to mean solar day, this gets accumulated in 10 days, 15 days, 20 days, and the 30 seconds add up to creating this 14 and 16 minutes. That's how the big difference comes. So this decrease of 16 minutes, that will happen when reaching here, the duration will be reduced by 20 seconds, and that will continue to be accumulated, leading to lesser of 16 minutes time. And when this side, when the extra time will be accumulated, let's say 30 seconds over 10 days, 15 days, 30 days, this will lead to extra time being consumed. Hence, the apparent solar day will be longer than the mean solar day by 14 minutes. This is how the big difference value comes in this. So remember it, it's important. So I hope you have noted it down. Let's erase it and proceed towards the definitions and important points. So, sidereal day, time interval elapsed between two successive transits of the first point in Aries over the observer's meridian. The use is that it's used for scientific purposes by scientists or for any astronomical researches. The duration that you need to remember is 23 hours 56 minutes, and these are basically the all the important things. Also, if we talk about what kind of questions that come from these, we'll cover it in the end of the video. So note it down, please. After that, if we talk about the apparent solar day, then the definition would be almost the same, just a few changes that I will erase and write it down. So similar, just the real sun's transit over the observer's meridian. The use, it will, yeah. So it's not used for any scientific purposes, but basic use, if we talk about, then the sundials, which is completely dependent upon the sun rays falling on it, that will be affected by it. So we could just write for information the sundials. And the duration, so just a second. varying from 2344 to 2414. Easy to remember, ending with 4. Yeah, please note it down. And very similarly for the mean solar day, not much changes. The sun will become imaginary, the duration will become exact 24 hours, and the use will become the clocks that we use, either 12-hour clocks or 24-hour clocks that we use in our homes, that are dependent upon the mean solar day. Let's write it down. So this was all about the types of days. Now you could copy it down and then we could proceed towards our last topic, the twilight period. So please copy it down. So I hope you have noted it down. We can erase it now. Okay. So now we're going to start with the very famous topic, twilight period. Very important in aviation for a lot of things, as a lot of operations depend on it. So you must have a good knowledge of it so that later on when either question in interviews or using in actual scenarios, you can understand what's happening, how to decode it. So for twilight period, there are two base terms, very important terms, and all the definitions are based on the two terms. So we will start with the two terms that are first visible horizon and sensible horizon. So we'll quickly draw a diagram and understand first using that what are these. Later on, I'll also write down the definitions for you to later on see. So this is our Earth. Let's say we are standing here. This is us, the stick figure. So what does the concept of visible and sensible horizon says? Sensible horizon is the horizon that does not cater for atmospheric refraction. That means if we are standing here and we draw a straight line, that will become our sensible horizon. So let's draw one. And the concept of visible horizon says that the objects that are present beyond our horizon, beyond our sensible horizon, we can also observe that because of the atmospheric refraction. So what will it mean if we draw it here? So let's say this is our sensible horizon. I'll write S. So our visible horizon will be affected by atmospheric refraction too, like this. And because of this refraction, we will be able to see items that are present below the sensible horizon too. Let's draw something. Let's say our friend is standing here. His name is GK. So GK is standing here. what will our name is, let's say NK. So NK will be able to see GK even if he is standing below the sensible horizon. Why? Again, because of the atmospheric refraction. So there must be a value of something like the value of an angle present between the visible and sensible horizon, 34 minutes. Let's first write it down. For those who do not know what are minutes, these are not the minutes made up of 60 seconds. This is different. So 1 degree is also broken down into 60 minutes, and 60 minutes, each minute in them is also broken down into 60 seconds. So this is 34 minutes. It is approximately half of a degree. Let me write it down. So this is the sign of minute, this is the sign of second, and here we are 34 minutes below the sensible horizon, the visible horizon is. So this is what sensible and visible horizon is. I'll write down the official definition given in books later on. Now let's understand how it comes into use in twilight period. So there are two terms. First of all, what is sunset? And in twilight period, there will be three definitions: civil twilight, astronomical twilight, and nautical twilight in the same order. So why are these horizons come into our use? So first of all, for the sunset, we use the visible horizon. Given in Oxford Air Navigation and R.K. Bali, they say that when the sun's tip is just touching the visible horizon, or we can say the sun's top limb is just above the visible horizon, we consider that time as the sunset. So now we'll also see its relation with the sensible horizon because it's going to come into use later on. So we joined one line to this, and this angle is 16 minutes. Just a second. What is this 16 minutes angle between what? So if we connect our horizon with a straight line with the sun's center, it will be again 16 minutes below the visible horizon. Why? Because sun has a width too. That is also going a little below if we are considering the center. And why do we need to consider the center? Because the definition of civil, astronomical, nautical twilight says that it is always measured according to the sun's center. That's why we need to calculate this too. So now just add it up: 34 minutes, 16 minutes, total 50 minutes. This is sun. This is earth. So quickly draw the diagram for your understanding, then we could proceed to the twilight periods, the civil, nautical, and astronomical, and how is it related to this diagram. So, मिटा दिया जाए. So now again NK is here, the sensible horizon is here. First of all, we'll understand what is the twilight period by definition and what are the three types again by definition. So the definition of twilight period is the time after sunset and the time before sunrise when there is light in the atmosphere around us, but we cannot see the sun. Then why is the light? How, from where does the light come? So obviously because of all the refraction that's happening, all the refraction from the air particles, etc. That leads to the ambient light, very low dim light in our atmosphere, and that time interval is called twilight period. The three types of twilight that I mentioned earlier, the definition says that in R.K. Bali book, the definition was when the sun is between 0 to 6 degree below the sensible horizon. To be precise, sun's center is below 0 to 6 degree and below sensible horizon. That period of time is called civil twilight. 6 to 12 degree, when the sun center is between 6 to 12 degrees, that time period is called the nautical twilight. And in the end, 12 to 18 degree, that if the sun center is between that arc, then that time interval is called astronomical twilight period. So these are the three types of twilight periods, and easy to remember: 6 to the 12, 6 to the 18. So divided into three parts, three twilight periods. Now let's try it here. The definition: the center of the sun is 0 to 6 degree below. The line is a little bit curvy, forgive me for that. But here is this 6, 12, 18 degrees. Also, let me write the types of twilight. This. Please note down, there is one more thing that I will add after this. So you could pause the video and note it down. Yeah. So I was also studying the Oxford Air Navigation, the air navigation book published by Oxford. So in that I found one thing new. What was it? It said the civil twilight began not at 0 degree but at 50 minutes below 0 degree of sensible horizon. Now, first of all, I thought, why is that? How is that happening? What's the significance of it? So, if you reverse the video and go 3 minutes earlier, the diagram which I made here earlier, did you notice the visible horizon being 34 minutes below the sensible and the sun's center being more 16 minutes below the visible horizon, which added up to 50 minutes? Right. From there, the 50 minutes came. And why the final value was 50 minutes to 6 degree? Because the definition of the twilight period says the sun's center should be below the sensible horizon. So what's happening here? What's happening is the sunset period is considered when sun's top limb is below the visible horizon, and at that time the arc created between the sun's center and the sensible horizon was 15 minutes, and the definition of the twilight period says the period after sunset when there is ambient light, when there is a little bit of ambient light. So when it is saying after sunset, so we need to consider sunset for the initial reference, and from there came the point that At sunset, the sun's center is 50 minutes below the sensible horizon. So, here, if generally for exams, this is the main values that comes, civil twilight 0 to 6 degree and like that. But for very precise knowledge about this civil twilight, you could also say it is 50 minutes to 6 degrees, the range. That is just for extra precision, but for example, this is again, remember this. This is the final and more important part. So, note it down again. Yeah, the heading, twilight period. Astronomical. If you have noted it down, there are few important points that you need to remember for your knowledge. It is less asked in exam, but very important for future interviews. Few questions could be asked. So I'll write down few points on the board after this. So please note it down first. मिटा दिया जाए मिटा दिया जाए So let's write few definitions and important points, starting with the definition of twilight period. So it is the time before sunrise, after sunset, when the diffuse light is available and it lights up the atmosphere a little bit. And one important thing about it is that VFR operations is possible in this. What are VFR operations for those who don't know yet? VFR stands for Visual Flight Rules. These are the operations when we navigate basically visually from what we are able to see in our surroundings. So basically we take few locations such as some big factory, some big lighthouse or some windmill, something like that, and we use it to navigate. Now, if the light was not enough itself, what will we see? There will be nothing visible. Then how we will navigate visually? That's why the twilight period is the ending time of VFR operations. After the twilight period, we can never carry out VFR operations. So this is the first point. Then we'll also see the definition of sunrise and sunset as very nicely explained in the book by R.K. Bali sir. So let's write it down first. So this is how Arkivali sir has explained the rise and set of not only sun but any heavenly body like moon. So moon rise and moon set is also dependent on this, whether the top of that heavenly body, sun, moon, any other planet, has risen above the visible horizon or has gone below the visible horizon. Note it, it's visible horizon. Then it's called to be risen, sunrise, or set, like sunset. So this is the main governing definition. There are a few more points that I'll write after this, so please note it down first. I hope you have noted it down. We are going to erase it, and there is something really fun thing coming after this. I'll actually show you where the sunset sunrise tables are given and information about that. So I hope you've written it. One more thing to note down, the sunrise, sunset, sunrise tables, twilight periods, etc. are given in a book type thing called Air Almanac, and it is given in LMT, local mean time. We'll study LMT later on too. For now, basically, first of all, write it down, then we'll understand. So, what is this? Except the Air Almanac, there is one thing that you could access right now using the internet. That's AIP, Aeronautical Information Package. So Indian AIP contains all of the information regarding that you need to know while flying in India. So let me show you the sunset sunrise table in AIP. So I hope it is visible in this. Yeah. So if you see General 2.7 of AIP, it has all of the information that you need to know. First of all, it has given all of the airports, aerodromes list on which page number you will find the information. So let's start with, let's see Agartala Aerodrome. So what all information are given? Twilight from sunrise, sunset, twilight to month and day. Again, all of this information. And for all of the dates, we have this. Then for Agati Aerodrome, you can find your aerodrome too, like Delhi Aerodrome. So if you scroll down enough, you'll also find the sunset sunrise table for Delhi too. I hope it is visible. So like this in AIP, not only the sunset sunrise tables, but also the twilight period tables are given. And it is in LMT, local mean time. That means one is GMT or UTC, that's according to Greenwich Mean Time. That's one standard for entire world, but local mean time, it is for the certain place, depending on the place. We'll study it in detail, as I said earlier. So this is one important thing that you need to know. Where to find the tables. So if you go for flying, you will need this because you will fly VFR at first. You don't want to fly after sunset. It's not according to rules to fly VFR after sunset. So for all of these things, you will need this tables. This thing. There was one more thing to note that I'm not writing down. You can write down if you want to. Small piece of information which I said earlier. The twilight periods, it is with respect to the sensible horizons, and the sun's center is being considered while all the degrees you saw, 6 degree, 12 degree. So it is the sun's center which should be below that degree marking to get into that twilight period. So for example, for astronomical twilight, 6 degrees to 12 degrees. So sun's center needs to be below 6 degree and above 12 degree to get called, so the time is called the astronomical twilight. So this is one thing, and for noting down, that's all mostly. Yeah, one more thing, few symbols in air almanac or few places it's used. Let me draw. These three symbols. I hope it's okay. White box, black box, and this is dashed. What is the meaning of these? Let me, I think it's confusing or what? Let me make it more black. Just a second. Yeah. So consider it as a black box, looks like gray, but it is completely black. Imagine it. Okay. So what are the meaning of these three things? Yeah, this means 24 hours sunrise. There is no sunset, there is no twilight period. This means 24 hours sunset, means dark, no sunrise, no light. And this means 24 hours twilight period. Sun not going up, not going down. The area remaining within the twilight period for entire time. How is this possible? Let me show you with a globe. So this is our globe. Yeah. So let's say this is, it's like this, and we have a sun here. Sun rays are hitting it. So you notice one thing, when it is completely, the sun is the lowest part, that is 23.5 degrees south, Tropic of Capricorn, most of the light of the sun would remain in the southern region. So what will happen? The south pole region, Earth will rotate from west to east like this. Earth will keep rotating like this, and sun's rays will basically be focused in the southern hemisphere. And one thing is different. For this region, that's the sun's rays focusing. Let's say this is the sun's rays, and Earth is rotating like this. You see one thing, this lower region is always receiving sun's rays, whereas this region, the upper region, is never receiving the sunlight. This is represented by this in sunset sunrise table. Let's say I made a airport in Antarctica. Okay, it's possible people go there. So if we have an airport there, and the sun is here in the southernmost point, and sun's rays are going here, there will be no night, 24 hours day. And that airport sunset sunrise table, or the tables telling about the place's sun movements, it will have this, the white box marking 24 hours sunrise. For northern hemisphere, if we have an airport on the north pole, let's say, then it will have this marking for the months in which the sunlight is not reaching it. After the earth revolves around sun like this, it will reach another point when the sun is focusing all on the northern hemisphere. The north pole will have 24 hours sunlight, whereas the south pole will now have 24 hours dark. This is how these two gets created. Similarly, this is 24 hours twilight. So as the sun is here, let's say, there will also be a place for which the sun will never rise somewhere in the southern hemisphere. It will always stay in twilight period, because Earth is rotating west to east like this. Okay, just a second. Yeah, Earth is rotating west to east like this. Sun is focusing here, whatever that place may be, and there will be left a place behind it or somewhere where there will always be twilight period. If you want, I can also draw it on the board so it's easy to understand. Sun, we have our Earth, and because of this tilt, let's say sun's rays are going like this. Like this. So when the Earth is tilted to the other side, the southern hemisphere will have these places when there will be 24-hour sunrise, no darkness, and there will be a place in northern hemisphere, there will be 24 hours darkness, and also there will be a place somewhere in this arc when there will be 24 hours twilight period. This is the marking for this. Let me write it down. So this is it. So major points have been covered till now. We will now do some important questions that are very probable to come in exams. So did we note it down? So can we erase it? Let's go. So this is the R.K. Bali book I'm using, and if you see, for every chapter there are important questions given at the back of it, for like after every chapter. It is very important. A lot of questions come from this book, many times same to same, many times similar, and I'm gonna write down few important ones that has come sometime, and I've got to know it from my friends, etc. So question 7 first. Important question, very important question. The angle between the plane of the ecliptic and the plane of equator is approximately, one new word, ecliptic. First let me write it down, then we can see for the answer. So first question that comes in mind, what is ecliptic? अभी तक तो ये पढ़े ही नहीं, ये क्या आ गया? So sun, earth revolves around sun, we know that. Now if we imagine it is not the earth that is revolving, let's imagine it is the sun that is revolving around earth. So how would it look? The topmost point would be the 23.5 degree north, Tropic of Cancer, lowermost Tropic of Capricorn, and it will look like the sun is revolving this region, then it will come here above equator, and then above Tropic of Cancer. It will look like the sun is revolving. We are imagining it. Of course, it is the earth that revolves. Let's imagine it is the sun that's revolving. So the path the sun will trace while revolving that path is called the ecliptic. So now we can understand this question. Plane of ecliptic, plane of equator. Equator, let's extend the plane. Did ecliptic, 23.5 degree north, let's extend it. So I hope you can imagine this. First plane, second plane, and the angle between them. So the angle will be the same up to which the sun goes, the topmost point, that is 23.5 degrees. This is the answer. So this is one new term that comes, generally not given in books maybe, but remember this, ecliptic. Whenever you see the word ecliptic, reverse the order. It is not the earth that's revolving around sun. Imagine it is the sun that's revolving around earth, and the path, ecliptic. That path is called ecliptic. Okay, one more question. Question 18 of the solar system. Yes. So again a new term came forward, celestial horizon. What is this? Never seen this? Right. So let's understand this first, then we'll automatically understand the answer. Let's say we are this point. We are like a point in space, right? Let's make few stars. Let's say we are left alone in the space, random stars. Now, this is us. The horizon exactly perpendicular to us, like a big dish, like a big plate. That is the celestial horizon. So let's make it. This is the celestial horizon. This divides the entire volume into two halves. First, upper half, which we can see, and second is the lower half, which we cannot see. It could be done like this. This is our Earth. We are standing here, and the outward going horizon will be celestial horizon. Also, one more issue in the first option, tangential to horizon, but which kind of horizon? No info. It could be visible horizon, sensible horizon. Nothing is written here. But on the second point, we are able to see the celestial horizon, and it makes perfect sense. The celestial horizon going outwards, and if we go 6 degree below it, like this. So if the sun's altitude is 6 degree below the celestial horizon, it will definitely enter the twilight zone, the civil twilight. So the correct answer will be B. Sun's altitude 6 degree below the celestial horizon. If you want to understand better, so I'll act like I am the observer. I am standing here. I could see all around me. This plane going straight outwards, this is the celestial horizon. If I see 10 kilometers on any side of mine, and if I try to see below, all I see is ground. I won't be able to see the stars or anything below this horizon because there is earth below me. That is the significance of celestial horizon. So I hope you have understood it. These were the important questions which had few new terms. If you solve questions from this book or somewhere else, and if you have doubts in it, so feel free to contact me. As I also said earlier, I could help you with your doubts, and it's completely free of cost. There is no charges on it because again, I'm also learning. I also would update my all information sources with your doubts. So feel free. Let me provide you with my email and phone number. So this is my email and my phone number. That was all for this chapter. See you in the next video. Jai Hind.